Hello and welcome to GrossiMath.com, where math is for everyone. Today we're going to take a look at how to put an expression into standard form. This is a very simple process, so let's get started. Okay, so standard form is a really easy thing to do. It has a kind of fancy name, but basically what we're doing when we do standard form is we're really just organizing our terms. I have a few previous videos about how to identify terms, so if you haven't seen those yet, you should probably go back and take a look. Okay, so let's take a look at some expressions. I have here some example expressions, and the first thing we always do when we're looking at an expression is try to identify our terms. So you can see here that I have labeled that this is not standard form, and over here you can see that I have labeled that it is standard form. So the first rule of standard form is that a constant, which is a constant is a term that has no variable. Constants are going to go at the back. Okay, so this positive 3 is a constant term. So now in our previous videos, we've learned that you're allowed to switch terms around. So I hope you realize that this plus sign right here is actually the implied positive sign from this leading 3. Okay. So there was a positive in this box, but it's just implied, meaning that we don't see it. So when we switch these two around to make it be standard form, all we're doing is putting our constant term at the back. Anything that has a variable will be at the front. Well, what happens if we have more than one term with a variable? So let's take a look at that next. Right here, again, I have an expression. I'm going to go ahead and identify my terms. Okay, and here's another expression. I'm going to identify the terms. And you'll notice that the terms in both of these expressions are the same, right? -1, -1. -3x, -3x. Positive x squared, positive x squared. And don't forget that this plus sign became an implied plus sign, so we don't have to write it. But this little plus sign is technically there. I'm just pointing that out because people often forget. Okay, so what is the purpose of standard form? Well, the idea of standard form is to organize our terms. So you can see here I said put the constant at the back. That rule still worked. Look, the constant term is in the back, -1. Remember, a constant is a term that does not contain a variable. So now we have here x squared in the front, and here we have a term with just an x term. Okay, so with just an x variable. So in this one the variable is x squared, and in this one the variable is x. So you can see that we're going from the biggest exponent to the smallest exponent, because this would be just a regular x, right? This is x squared, so there are two x's here. Here there's just a regular x, so technically this could even count as an implied 1. Okay, this is x to the first power. And then this one right here is blank, so this would be kind of like saying x to the 0 power. There are no x's listed in this box. So we're just going 2, 1, 0. The important thing to understand is that the coefficients, or these numbers that are in front of these terms, we really don't care about them. We really don't care about them. We only care about the variable and the variable's exponent when we're talking about standard form. So it's simple stuff. There's not a lot to think about. Watch. Look at this long one, okay? X to the third, -x to the fifth, positive 2x, and -5. Okay? Well, here I can see that this is not standard form. Why is it not standard form? Well, it's not standard form because the 5 should be at the front, because the 5 is the biggest exponent I see. So therefore, this -x to the fifth, this term should be my lead term. The reason it should be my lead term is because it has the highest exponent. So look here, now I'm doing standard form, and look, right away, the first term I put is my -x to the fifth. So this term is now taken care of, this one right here. I'll put a little slash on the box. So -x to the fifth is already here. Then I put positive x to the third. Why did I put positive x to the third? Because when I look at all my exponents, my variable exponents, when I look at those, I see that that's the next biggest one. So it's kind of like putting them in size order. We're going to go from biggest to smallest. Okay, so now what did I put next? I put positive 2x. Well, positive 2x, as I said, an x by itself basically counts as x to the first power. There's a little implied 1 there. We don't put it. Why? Because if it's just 1, we don't really have to know that there's 1. The fact that there's a letter x there kind of lets you know, oh, there's one of them there. Well, what about this one? Negative 5. Well, remember what I said with standard form. Anytime we see a constant, we're probably going to put it to the back. Okay, so the negative 5 went to the back. You could also think of it as having x to the 0. In other words, if this just means x and it shows you that it's to the first power just by being there, well, by not being there, that kind of counts as x to the 0. And then you could see that the exponents do line up in order. 5, 3, 1. And remember, I'm not saying 5 to the 0 power. I'm saying that there is not an x here. I'm just messing around by putting an implied x. There's not an x there, but you could dream that represents the number 0, so that you could kind of have an idea of why constants go to the back. Okay, so 5, 3, 1, and then a constant representing 0 exponent on the variable. All right, so let's move along to some examples. Let's try and do this. If you wish, you can pause the video here and attempt it yourself. Step 1, always identify your terms. That is the heart of algebra. Okay, step 2, we're going to move the terms around. I crossed out this part that says use the commutative property. Why? Because, as I always say, math is for everyone, and the words commutative property seem to get people nervous. Well, the normal meaning of the word commutative property is to move the terms around. Okay, so if you need the vocabulary, you can go ahead and learn that, but you certainly don't need it to do algebra. And let's put this into standard form now. Well, what am I looking for? I'm looking for the biggest exponent on the variable. So I look at my variable here. This counts as an implied 1. I look at this one. This is a constant. So right away, I know that this one's going to go to the back. So I'll save that for last. And here I see positive 2x squared. So my variable exponent here is a 2, which makes that my highest exponent. So guess what? That's going to be my lead term. Your lead term, after you put it into standard form, your lead term should be the one that has the highest variable exponent. Okay, so 2x squared. Again, and for one of the final times, I got to stop repeating this, but this plus sign didn't just, disappear. In a way it did, but actually it is there. It is an implied plus sign. Okay, so it is there. It's just we don't write it because it has a special honor of being the lead term. In fact, I won't even put the little dots. Okay, because we got to start getting used to that now. Okay, so this one is done. Now which one am I going to put? Well, this one has to go to the back, so that's a good hint. And also here I see a variable with a 1, so that looks good. Now this is positive 3x. Again, that implied plus sign pops up. I cannot, and this is so important, so important, I cannot just put 3x like this. If you do this, you've messed up your expression, and really you've messed up your term counting, okay? You always want to have the expression have the same number of terms after commutative property. So look, here I have a positive 3x. Here I have to show the plus 3x because this is no longer the lead term, okay? All right, now I'm going to do the negative 5. Obviously, that is a constant, and it goes to the back. And there we go. That my 3 terms are still here. They're still in great shape. There's the first term, the second term, and the third term. And I have made it into standard form. Okay, so let's go to the next one. Here I made a much larger one, just so you could see what would happen if you had a crazy looking expression. And it's also going to be part of our problem solving playlist. So let's go ahead and identify our terms. So watch what I'm going to do. I look here, and well, you could pause it and give it an attempt if you wish. Right here, I'm going to look for my highest variable exponents, right? So here I have a variable, but this one is to the first power. Here I have no variable, so this is a constant. Here I have a variable, but again, that's a 1. Okay, so far my highest exponent is a 1. This one's a constant, so there's nothing to be worried about there. Here we go. Now I have an x squared. So this is my new highest number, and this one has an x squared. Okay, so what I'll do is I'll put my x squared terms in the front. So if you have more than one, you can just kind of put them in order. So in this case, I'll put positive 3x squared, and then I'll put my positive x squared term, okay? So now I've taken care of both of these. Now, it's kind of neat, in my opinion, to have the 3b here, and then technically, if you see a variable by itself, its coefficient, meaning the number in front of it, is a 1, okay? So right here, this would be basically a 1. So if I'm going to have two x squared terms, I like to put them also decreasing by the coefficients. So like, for example, 3 and then 1. I think that's nice. So I do that. But the most important thing, even if you had messed that up a little bit, because later on we'll learn that it's not going to matter in the end anyway, because we're going to do something special. But that's another video altogether. But here, the most important thing, the secret of this lesson is x squared, x squared. And now I've got a little group of x squareds. Now I'm going to go ahead and go to the next one, which would be my variables that have the number 1 as their exponent, which guess what? That's negative 4x and negative 2x. Okay, so I'll just put negative 4x, negative 2x. And again, I'm not going to bellyache about the order because later we're going to learn some special skills about what to do with those, okay? So look, here I have my little exponents of 1. Well, now, let's see the ones that are constants. I have positive 5 and negative 3. I like to put the positives in front personally, positive 5, negative 3. But again, the most important rule is, look, once again, we have a group of x squareds, we have a group of regular x's, and we have a group of constants. So again, we see our exponent decreasing from squared to an exponent of 1 to constants which don't have a variable exponent. So we're still organized. We're still going right down the list. Okay? So I'm not going to keep that 210 there because that's not really a good representation. I think it's better to see them as part of the terms. So here again, how many terms did I have? 1, 2, 3, 4, 5, 6. And here, how many do I have? 1, 2, 3, 4, 5, 6. Okay, so that's the secret of changing an expression into standard form. All right, guys, I hope you learned something today, and I'll see you in our next video. Have a great day. Don't forget to visit the website where math is for everyone, www.grossimath.com. Oh, and don't forget to like and subscribe.